Tom Kurz is an astronomer at the Royal Observatory in Greenwich, here to shed some light on this, because the probe isn't getting enough, is it, Tom? That's the biggest problem here. Why is it so precarious for the Philae lander?
Well, we're sitting on chairs here in the studio and we can feel the Earth's gravity pulling us to the floor. It gives us our weight, our natural weight. But even though this comet that we've rendezvoused with and landed a probe on weighs 10 billion tons, the gravity is so low at the comet's surface that we could quite easily jump off. In fact, we could quite easily tip something off just by giving it a gentle nudge. So to illustrate this, I have a small prop here.
Okay.
This is a AAA battery.
Tiny.
So if you hold out your hand, I'm just going to pop this in your hand. Now, this probe that has landed on this comet weighs 100 kilos here on the Earth. But this is the effective weight that it has on the surface of the comet, about 10 grams.
So you can see why, when they tried to land it at first, it bounced off. Almost a kilometre up into the ether.
That's right. So one of the jets that was designed to a thruster that was designed to keep the probe on the surface whilst it harpooned itself to the surface, failed to fire. And they knew it wasn't going to fire.
Are they going to try again, or will that just push the thing off again into space?
I think the engineers and scientists working on this at the moment are very wary about doing anything that might move the probe. The critical science mission for this probe is to deploy a drill and to collect a soil sample so we can sort of chemically analyze the surface of a comet for the first time in real detail. But just deploying that drill can move the probe in such a way, in the position that it's in now, that makes it impossible. On the other hand, they also need to save power, and some of these actions would cost them a lot of power, so that's another consideration.
Yeah, just to remind us, what the comet is actually spinning, and the probe is in the shadow of a cliff at the moment, so that means what for its solar panels?
When they chose a landing site, initially they'd picked a site which received quite a lot of daylight. The comet spins once every 12 hours or so, and the scientists and engineers had chosen a site where they would get something like 6 or 7 hours of daylight for every rotation of the comet, but now they're down to about 1.5 hours, which means the batteries are not recharging as much as they should be, which means they're either going to have to take away some of the instruments, turn them off, or they're going to have to simply prolong the mission and stretch out the goals so that they can perform all of those mission goals a little bit more slowly.
Let's talk about the positives then that we've got so far. The pictures we've seen look quite incredible, even to the layman like me, and also just landing on the comet in the first place, even if they didn't hit the bullseye where they wanted, was still an amazing achievement.
What you have to remember is that this mission, the Rosetta and the Philae missions, to rendezvous with and to land on a comet, that was unthinkably ambitious, even from the moment of conception. And here, after 10 years in space, it has succeeded. We now have a probe, thanks to this cooperation of over 10 European countries and more countries beyond Europe. We have a probe on the surface of a comet that's returning valuable science data from the surface of a comet as we speak right now. So this is absolutely extraordinary. My colleagues and I at the Royal Observatory, we were watching this unfold just in awe, absolutely in awe, because it's astonishing. It's a real technical achievement, and we stand to learn so much from the data that's coming in from this probe. It's an absolute Swiss Army knife of instruments that's really doing a great job at studying this comet in detail.
Tom, there's your battery back.
Thank you very much.
Many thanks indeed.
Thank you.